Hi, welcome back to Cybersecurity for Everyone. I'm Dr. Charles Harry. In this episode, I want to talk a lot about how data actually moves from one point of the earth to the next. And it's a process that we call encapsulation. So how does data actually move? We know from our prior conversations that the internet allows for a broad set of connections between interdependent networks, and they communicate with one another. The World Wide Web is a set of content that sits on top of those independent networks. But the question is, how does data actually move from one point of the earth to the next? If I'm in Maryland and I want to communicate with someone in Mumbai, how does that actually happen? How does that data move from one point of the earth to the next? And that's what I want to talk about more today. So if I'm an individual sitting in, let's say, Paris, France, and I want to communicate with someone else, let's say in Maryland, how does that actually happen? Yes, of course, we want to look at the broad set of interconnections between networks. This is just a simple visualization of a lot of independent networks on the internet. But the question is, how does that data actually move? That's the concept of encapsulation that I want to talk about a little bit in this episode. So the ability for devices to communicate with one another require instructions. And we call these instructions protocols. We've talked a little bit about some protocols in earlier episodes. Some of these protocols, some of these instructions relate to applications that you're using. Still others relate to the routing of that information. And still others relate to the physical mediums in which that information is transmitted. We bundle those instructions together using a concept that we call encapsulation. So if you're using an application, whether it's social media or email or even a web processing application that you're eventually going to send in a file transfer to another computer, there are a set of instructions that are included along with it that tell the device and tell the network how to interact with that information and where to send it. So depending on the application that I'm using, there are a set of instructions. Those instructions are then paired with other instructions that deal with the routing of that information. And then further, those instructions are then passed down to the physical medium, how that information is actually transmitted over some sort of energy waveform. Now we're going to talk more about specific portions of these instructions in other episodes, but it's enough right now to understand that these instructions are included. They're encapsulated within one another, kind of like Russian nesting dolls. The dolls in which a smaller doll fits inside a larger doll, which fits inside yet another larger doll. That's in essence what we're talking about. So we use something called the OSI model, or the Open Systems Interconnection Model. And it's a way to think about communications functions that are completely independent of the technology or the structure underpinning it. And there are multiple what we call layers involved in this model. And those layers together form what we call the stack. So let me show you kind of a visualization of what I mean by the OSI model. If I want to send and encapsulate data, so I'm actually using a laptop and I'm writing an email and I want to hit send on that email, I need to encapsulate those instructions in some sort of structure. And so the OSI model has 7 different layers. And remember, those layers form the stack. So we're going to start up at the very top here at the application layer. And that information is then packaged and encapsulated at different layers. So we have a presentation, a session layer, transport, network, data link, and physical. Now, for the purposes of our conversation, we're really only going to talk about 3 layers in this model. We're going to talk about the application layer, we're going to talk about the network layer, and we're going to talk about the physical layer. And we're going to talk about those layers in future episodes. But it's enough to understand that the instructions that you are providing at the application layer is encapsulated in all these other layers as well. That information, once it's all packaged up, is then sent over a physical medium. That could be light, it could be radio waves, it could be microwaves. We'll talk more about that in a different episode. But that waveform can be transmitted from one point of the earth to the next. So if I want to communicate with my friend in Mumbai, and I'm in Maryland, all that information that's incorporated in that email is encapsulated, all these various instructions about where to route it and how to send it and how to deal with that information is packaged up and sent. My friend, once they receive it, their computer receives it, now can unpack all of that information. The instructions are included. Once that information is received, it gets unpacked. So it moves away from just the physical medium and gets unpacked. And then the network understands what to do with that data. And then later the application knows what to do with that data. So that email that I've sent my friend is now received, the instructions are unpacked, and now that email can actually be read. So encapsulation is fundamental. It's a fundamental concept in the global telecommunications environment. And it includes data from the applications that you're using, but it also includes instructions for the recipient's application, as well as all the infrastructure that is required in order to route it. That data, the packets, the frames, the bits, all the pieces of information that are included are all sent around the world using this globally interconnected set of networks. Laptops, phones, critical infrastructure, and all the other devices that we know and love send and receive information this way. So why does this matter for us when we want to talk about cybersecurity? Well, hackers leverage weaknesses in those different layers. Because remember, the layers represent a conceptual model. But within each one of those layers are protocols, instructions, how to deal with that information. And some of those protocols are pretty old. They're 40 or 50 years old. And so some of them have weaknesses. And hackers look for the weaknesses in those instructions. And they use those weaknesses to help them steal information or to disrupt services. Understanding how data is packaged, routed, transmitted is absolutely fundamental to understanding the set of threats that we face. Complexity in the technical systems and the human organizations they support is absolutely at the heart of cybersecurity. That's why we need to talk about encapsulation and the different layers of the OSI model. So what are the takeaways? Information must be transmitted from one point of the earth to the next. That's how we communicate. The instructions for that data and how it's packaged, routed, transmitted is done through a process called encapsulation. The OSI model is a conceptual approach for how we understand those layers in the stack. And the potential weaknesses at each and every one of those layers are at the heart of cybersecurity. That's what the hackers are exploiting when they want to steal your information or disrupt a critical service. In our next episode, we're going to talk about the application layer. I hope to see you next time.